The ability to disable or remove the global interpreter lock, or the GIL, as it's so lovingly referred to. Let's start at base principles. What is the GIL? And then after that, why would you want to remove it?
Right. So the GIL is basically a ginormous lock all around Python. So when like Python is really, is the language, but it's really doesn't exist, right? Like it's an abstraction, and really normally there is a second language behind. In C Python is C, which is C Python is the default implementation of Python that normally people use. There are others, but then when this program that is the Python interpreter is executing Python code, it can have multiple threads at the same time, and all these little objects that Python exposes could be mutated at the same time, which is a problem. And Python in particular, C Python as well, and most of the implementations is reference counted. This means that to decide if an object is still alive, or the interpreter can actually get rid of it, we have this little number inside every object that tells how many different structures or fields are using it, right? And when this number reaches 0, we know that we can remove it, right? But as any person who has done some multi-threading in computer science knows, having a little number being mutated by multiple threads at the same time is not bueno. So the solution is basically to add a ginormous lock all around the interpreter. So because we don't know what the threads are doing, we need to just basically lock the entire thing. So this means that only one thread at a time can be accessing Python code and executing Python code, which means that you can still use threads, because those threads can switch from one to the other, which is what we call concurrency. Like you don't need to wait until one thread finishes to start the other. So they interleave, but there is no parallelism really, because only one thread at a time can be executing Python code, which is a big problem in these days when we have machines with 120 something cores if you have Threadripper or servers, right? Or even your phone, right? Like your phone have plenty of cores. And right now, you are running Python on iOS, which is now a thing, by the way.
So what you're saying is, when running Python, you can switch quickly between cores, but you can't actually run the same code on multiple cores at the exact same time. So you're saying it's concurrent, but it's not parallel because of that lock, one at a time, and it can switch at the speed of light, but no true parallelism until now.
Right. So there were a few ways in which we worked around this obviously huge design limitation. So there are plenty of cases in which we're confident we can drop the global interpreter lock for what is happening on a particular thread. So if your particular thread is doing some big NumPy computation that is only on the sides of numbers that are not shared as Python objects, like you can drop the global interpreter lock in the time that this computation happens, so you can let other threads execute Python in that time. If your thread is waiting on a blocking network connection, it also does not need to hold the lock, because that particular moment in time, there is not going to be any Python code executing. So you can give that GIL, right, to somebody else. So there are special cases in which we were already sort of parallel more than not, but it is very implicit. It depends on us carefully finding all those special cases and enabling them. And in the end, it does not scale for regular user applications. So if you just write Python code that loops over things and just executes some string concatenations, does like all these regular things that you expect from a Python program, most of the time you're not going to be seeing any parallelism there.
Well, and what is worse, one important thing here is that technically GIL is more than just a lock. It's a condition variable, which is a very specific kind of synchronization primitive. It's a Boolean that tells you have it or not, and an actual lock. And the thing is that you cannot select which, like when one thread says, "Oh, I don't need the GIL," like someone else, pick it up. You cannot select which one is going to do it. Like this is up to the OS. Like you're using Linux, so the Linux kernel decides who is the next one, and this can be not great because like the Linux kernel may not know what you're doing. So you can have one thread